All right, this is Chapter 3, Section 1, Graphing Systems of Equations. A system of equations is a set of two or more. Later, you're going to find that we're going to do systems of three. But for now, set of two or more equations that use the same variables. If the graph of each equation in a system of two variables is a line, then the system is called a linear system. Now, when we solve these, you're actually looking for the point where the two lines intersect. Sometimes they don't. Sometimes the lines are parallel. And so in that case, there would be no solution. But if they do intersect, then the intersection point is the solution to the system. So a solution to a system of equations is a set of values for the variables that make both equations true. You can solve some linear systems by graphing, and that's what this section is about, graphing. So remember, you need graphing paper for your homework. The points where both or all lines intersect represent solutions. So if they're linear, they're only going to intersect in one point. How to solve the system? Well, you're going to first solve each equation separately for y, which means you're putting them in slope-intercept form, so you can graph them. Next step, once you have them in slope-intercept form, is to graph each equation separately and you might want to use two different colors. That sometimes helps. Graph each equation separately, but on the same coordinate plane. And then we're going to look where the lines of the graphs intersect. Excuse me. So, for example, we have this system, and notice that the two equations are in standard form. You must convert them to slope-intercept form. So I'm going to say, I'm going to move x to the other side. So this becomes 3y equals negative x, because I'm subtracting it, plus 2. Divide each term by 3. Y equals negative 1 over 3 times x plus 2 over 3. This is the first equation that I need to graph. So my y-intercept is 2/3. Right? You're not always going to get whole numbers or integers. So I'm going to go up about 2/3 of the way. That's my y-intercept, positive 2/3. And then my slope is down 1 to the right 3. So if I'm starting from a 2/3 spot, I have to end up at a 2/3 spot. So that's down 1 to the right, 1, 2, 3. Down 1 to the right, 1, 2, 3. Down 1 to the right, 1, 2, 3. I'm going to draw that line. I would do these separately because if you just put dots on your coordinate plane for both lines, it might be a little bit difficult. to tell which dots go on which line. So there we have that piece. Now this piece, do the same thing. 3x plus 3y equals -6. I'm going to move the 3x because I want the y on the left side. So 3y equals -3x. Subtract 6. Divide all by 3. So this becomes y equals -x, or -1x. Subtract 2. There is my second equation. I'm going to plot the y-intercept, -2. I'm going to use my slope of up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1, or down 1 to the right 1, down 1 to the right 1. That should be enough. I'm going to use a straight edge to make my lines longer. You have to draw the arrows because the line keeps going. And notice that the two lines intersect at this point right here. And so that's my solution to the system of equations. What's the x value? -4. What's the y value? +2. So the solution to my system of equations is -4 and +2. And folks, guess what? You can check this, and I would at least check it on a calculator. Okay, so if I put a -4 in here for x, do a 3 times 2. 3 times 2 is 6. -4 plus 6 is 2. So that works. 4 times -4 times 3 is -12. And, you know, if you wanted to write that down, you could. I could say this would be -12. 3 times y is 6. Is -12 plus 6 -6? Yes, it is. So that check works. Okay, so if you have any questions, either watch the video again, post a comment on the homework discussion, or ask a question in class. Ready for side 2? Okay. We have a system, and this system is actually a vertical and a horizontal line. And x equals is a vertical line at where x is 3. So I'm going to put a dot at where x is 3. And anywhere on that line, the x value is going to be 3. So I'm going to draw my line, put my arrows. My other equation in the system is a y is 5. That's a horizontal line. And that's a horizontal line at where y is 5. So I'm going to put a dot on where y is 5. And I'm going to draw the horizontal line right through that point. And remember, if I want the solution to the system, I have to look at where the 2 points intersect. That would be this point right here. And the coordinates for that point, x first, x is 3 and y is 5. That is my solution. So I'm going to write the solution to the system is the ordered pair 3, 5. Okay, so excuse me, if you're pretty good at graphing these linear equations, you should not have a difficult time with this at all. All right, now the classification. Sometimes students get this messed up, so be careful that you know what you're doing. A system that has a unique, unique is something that's like no other. So a system that has a solution that's like no other, is called an independent system. Okay, so it doesn't depend on anything else. It's unique. It's its own thing. A system that does not have a unique solution, is called a dependent system. And I'll talk about these in a moment. I just want to get the notes filled in. A system that has no solution is called an inconsistent system. So, what do we mean by this? Well, if it's a unique solution, that means there's only one solution. The lines are going to intersect in one point. A system that does not have a unique solution is called dependent. Folks, that would be when you graph the same line on top of itself. So you have two equations, and they end up actually being the same line. And the system that has no solution, we call it inconsistent. Excuse me. This can be when your lines are parallel. So they do not intersect at all. So parallel lines have no solution. It's inconsistent. Lines graphed on top of one another is called a dependent system. And then when you have a unique one single solution, that's called independent. So you have some vocabulary that you will need to learn and or memorize. All right, so notice what the directions in our next examples are. It says without graphing, so no graphing here. Without graphing, classify the system as independent, dependent, or inconsistent. So what we should do first is solve these equations for y. We're not going to graph them, but we're still going to solve them for y. So when I solve this system, or this equation for y, I get y equals 3x plus 4. And when I solve this equation, now notice what I'm going to be doing here. I'm going to take the x over, and then I'm going to multiply by the reciprocal. And it's got to be negative because I need the y to be positive. Okay, so, I mean, we could show the work here. Negative 1/3 y equals negative x plus 1. The only way to get rid of the negative 1/3 is to multiply by negative 3. So that makes this become a y equals, this times negative 3 is positive 3x, and then this times negative 3 is minus 3. Folks, compare the slopes. Let's look at the equations and compare them. The slopes are the same. What kind of lines have the same slope? Okay, so we'll write here that the slopes are the same. So these lines are parallel. And without even graphing, I can tell this. And because the lines are parallel, I conclude that this system is an inconsistent system. Okay, so I could do all of this without graphing. There's my answer. Without graphing, classify the system. Okay, example 2, we're going to do the same thing. Put them in y equals form. This one, yay me, it's already in y equals form. Y equals 2x plus 3. This one is not. 2y equals 4x plus 6. Divide by 2. Y equals 2x plus 3. Oh, look at that. It's the same equation. This would be a line graphed right on top of itself. So, since it's the same line, we say that the system is a dependent system. And finally, the last one is another system. We're going to solve it for y, so we can compare the two equations. 4y equals negative x plus 12. And when we solve, y equals negative 1/4 x plus 3. Alright, 2x minus 8y equals 4. So I've got negative 8y equals negative 2x plus 4. Y equals, well, 2 over 8 would simplify. 2 over 8, 1 over 4, 1/4. Positive, though. And then 4 over 8 is a half. It's going to be negative. Now notice, the slopes are not the same. They are not the same. The y-intercepts are not the same. So because these have different slopes, so again, sorry I had an interruption there. Because the slopes are different, we say this system will have one unique solution. Because they will intersect at some point. We're not looking for the solution. We're just looking to classify it. So do these intersect? Well, yeah, they would intersect somewhere. So there's one unique solution, which means we conclude that this system is independent. Now I know we talked about parallel lines. You know, you're comparing slopes. For this system up here, the slopes were the same. We knew they were parallel, so there was no solution, and the system is inconsistent. Now, if the slopes are opposite reciprocals of one another, that means they would be perpendicular to one another. Now, perpendiculars would be an independent system because they do intersect in exactly one point. I'll show you at the top of our page. When we had a vertical and a horizontal line, they would definitely meet at right angles. And you know, think about it. This has an undefined slope, and this one has a slope of 0. So that's kind of like the reciprocal idea. And because 0 doesn't have a sign, we don't really see like opposite reciprocal idea going on. But if you had 0 divided by a number, and then compared it to a number divided by 0, well, they will be reciprocals of one another fraction-wise. Of course, we have to say the slope of the vertical line is undefined because you can't divide by 0. So when you're comparing the slopes, the only ones that will give you an inconsistent classification will be when the slopes are the same because they're parallel. And remember, parallel lines, you know, are two lines in the same plane that never intersect. So if the lines would be like that, because there's no intersection, then there's no solution, and the system is considered an inconsistent solution. So if you have any questions, ask in class, post on the homework discussion, or rewind the video and watch it again. You do have an assignment to do, and you must use graph paper. I have some in the classroom for you. Take a few sheets and keep it in your notebook. All right, till the next lesson. Have a great day.